All right, so let's start by going over the transformations that were listed in the learning objectives. We're going to go over vertical shifts, horizontal shifts, vertical stretch and compressions, and then reflections. Now, if you need to, please pause this video. We're going to write some stuff in here and we're going to write some stuff right here. You can pause this and then fill all of this out, or the rest of it, as I'm going through. This first table is the entire lesson. If you understand this first table, you're going to understand the rest of the lesson. To help you kind of understand this lesson, specifically differentiating these two from these two and differentiating these two, we have this table down here to kind of help us. But this is the entire lesson in this table. Okay. So, first, vertical shifts. If I have a function, and this can be any function, right? We went over 9 different functions last lesson with the key graph. So this is your absolute values, your square root, your cubic root, your x squared, your x cubed, technically your reciprocal function, and all of your linear ones. This can also be other functions like exponential and logarithmic functions. Whatever function you have here, your most basic key function, if you add or subtract something at the end, these are your vertical shifts, and these are predictable. So f of x plus k is going to shift your graph up k units. F of x minus k is going to shift your graph down k units. So let's look what I mean by that. Here in Desmos, I have the absolute value. Now, what does the absolute value function look like with its most basic graph? Hopefully you said a V. You can see here is my V, where that V, that point starts right here at the origin, 0, 0. Now, if I have the absolute value plus 5, it's going to take this V right here and shift it up 5 units. So now my V is starting right here at 0, 5 instead of at 0, 0. Now, if I have the absolute value minus 2, it's going to take this V that started right here at the origin, and now it's going to shift it down 2 units, where now it's at 0, negative 2. So when you have your function and you add or subtract something at the end of it, that makes it move it up or down, whatever that number is. Plus is up, minus is down. Your horizontal shifts we represent by h, and h happens within that function. So you have f of x plus h, and these always happen opposite of what we think. So plus in the middle, we think is going, if you're thinking of that graph, is going towards all of those positive numbers, which is to the right. This shifts to the left. When I have f of x minus h, minus we think of going over here to the left of all of the, where all those negative numbers are, but this one goes to the right. So for these two specifically, I'm going to come over here. And if you can remember, I didn't give myself really enough room, but inside, no, opposite, wait, what am I trying to say? Yeah, inside, I do promise I know what I'm talking about. Okay, inside, opposite. Outside, same. So what happens inside the function moves opposite directions of what we think. When it is outside the function, moving it up or down, it is predictable. So plus is up, minus is down. Inside, opposite, outside, same. If that doesn't help you, forget it. But if it helps, yay. Okay, so let's look at what this is looking like here. Oops, wrong one, but that's my daughter, and isn't she adorable? We'll get to her in a second. So here we have x cubed. And what does the function look like of an x cubed? Okay, hopefully you say a squiggly. Here's my squiggle. And so you can see it's kind of changing directions and squiggling right here at that 0, 0. So now inside that function, because it is x plus 3 quantity cubed, okay, it is happening within that cube. This is going to be left and right. So we think of plus as going over here to the right, but inside opposite, this actually is going to move it over here to the left. Now here I have x minus 7 cubed. Again, that minus 7 is inside that function because it is part of that cube. So we think of minus 7 as going over here to the left, where's that negative numbers, but that is going to be over here to the right, inside opposite. Now, let's just kind of take a break right there and come down here to this bottom table. This bottom table is going to help us differentiate between outside the function up or down and inside the function left or right. So if I have an absolute value, something outside would be the absolute value of x plus 1. If I have a square root function, that would be outside of that radical. So the square root of x minus 2. Same thing if you have a cubic root, any kind of radical, it happens outside of that radical. So the cubic root of x plus 3. Now these are all pretty easy to do when you're talking about inside and opposite. Here, outside means that whatever your number you're putting in there, it's not getting squared. So you have x squared minus 4. That minus 4 has nothing to do with that squared. So it's outside of that function. And same thing with that cubed. X cubed plus 5. It's not getting cubed. It is outside of that function. Now when this is happening inside and moving it left and right, it needs to happen within the bars. Under the radical, under the radical. The number needs to be with that exponent, it needs to be squared and it needs to be cubed. So inside the bars means that this would be the absolute value of x plus 1, all within those absolute value bars. Inside the function of a square root means it's under that radical. So the square root of x minus 2. Under the radical, the cubic root of x plus 3. To make it part of this squared, just like I had with this one here, you need to add parentheses so that number is getting squared. So now we have parentheses x minus 4 squared. Now this negative 4 is getting squared. It's inside that function. And then same thing here, add parentheses. So x plus 5 cubed. Okay, rewind this. If you do not understand the difference between outside the function, numbers getting added and subtracted, and inside the function, numbers getting added and subtraction within that function. This one moves them up and down, and they're predictable. So up, down, up, down, up. These are opposite. This would be left, right, left, right, left. All right, continuing on. Vertical stretch and compression. So I've already filled all of this out. And notice that they both have a times f of x. So whatever my function is, I'm going to have some number out front. If a is greater than 1, it is going to get stretched. If a is in between 0 and 1, it's going to get compressed. So for example, we have x squared. X squared looks like what kind of graph? hopefully say a U shape or a parabola. Here is my x squared function, that getting always starting right there at 0, 0. So now when I have 4 times x squared, that is getting stretched. So it's going to increase 4 times as fast because you're taking whatever x squared is and then multiplying it by 4. So instead of it being here at 1, 1, now it's at 1, 4. Instead of it being at 2, 4, it would be at 2, at 216. You're doing 4 times 4. Okay, so it's getting stretched. So now if you have 1/4 x squared, now that is getting compressed, so it's not going to increase as fast. Now, a lot of times students will say the vocabulary of skinnier and fatter. And I want to show you why we don't say skinnier and fatter and why we say stretched and compressed. And it's easier to tell this with some kind of picture. So here is my picture. This is my daughter. And so you can see here my picture here, and I have put arrows here to show you the margins. If I take her beautiful picture and I stretch this, and let's enable editing, and I stretch this, she is not getting skinnier. That photo, these margins have not changed. She is not getting skinnier. I'm simply taking that picture and stretching it. It has nothing to do with the width at all. Same thing if I smush her cute little face and I take this and I compress it. You can see here that margin did not change. So she's not getting fatter. It is getting smushed or compressed together. So we do not say skinnier and fatter. It is stretch and compress. And then lastly, we're going to talk about reflection. When you have the negative function, so negative f of x, where that negative is on the outside, that is going to be reflected across the x-axis. When you have that negative inside of that function, f of negative x, that is now being reflected across the y-axis. So let's look at what that looks like, and then we're going to finish this table down here. So the next function we're going to do is the square root. What does the square root function look like? Okay, this is the one I call your eyebrow. So it starts right here at 0, 0, and then it's going to keep going infinitely in only one direction. So now when I take the negative square root, it's going to reflect it across this x-axis here. And so now it's down here. Then when I have the square root of negative x, it's going to reflect it across this y-axis here. And so now it's flipped and going this way. So reflected across the x, reflected across the y there in blue. So again, very similar notation. Let's make sure we understand the difference. When it's reflected across the x, that negative goes outside that function. So outside the bars, outside of the radicals, outside of the squared. So we have negative absolute value of x, negative square root of x, negative cubic root of x, negative x squared, and negative x cubed. Now when it's happening inside of this function, it needs to happen in the bars under the radical, included in the squared or cubed, included in the exponent, whatever it is. So here we have the absolute value of negative x, the square root of negative x, the cubic root of negative x squared, and negative x cubed. Okay. If you can understand the difference between outside function and inside function, and you understand this graph that f of x means it can be any function possible, then you know the entire lesson. And if this is helpful, then let's use it. Inside opposite, meaning what's inside here is opposite. We think positive to the right, but it's to the left. Negative to the left, but it's to the right. And outside same, plus is up, minus is down, then bonus.